Hello viewers, welcome to Chemspawn Zone. Today I am going to discuss about the Aldol condensation reactions. So the aldehydes and ketones that possess alpha hydrogens, they show Aldol condensation reaction. Note this point, there should be at least one alpha hydrogen in the aldehyde or ketone to undergo Aldol condensation reaction. Here I have drawn four structures. The first two structures are aldehydes and next two structures are ketones. Now let us see that in the first structure, that is the structure of the ethynyl or acetaldehyde. We know that in aldehydes and ketones, the carbon which is bonded to the oxygen with a double bond is known as the carbonyl carbon. So this is a carbonyl carbon here. Now the carbon which is directly bonded to the carbonyl carbon is known as the alpha carbon. So if that alpha carbon has hydrogens, here we can see that there are three hydrogens. Right, those hydrogens are known as alpha hydrogens. Okay, so therefore in ethanol we have three alpha hydrogens and it will show Aldol condensation reaction. So in this structure, the structure of propanone or acetone, here we can find that this is the carbonyl carbon, and that carbonyl carbon is bonded to two alpha carbons. So in both sides we have two carbons, right? Directly it is bonded to two carbons. Those are alpha carbons, and both the alpha carbons have how many hydrogens? Three hydrogens, right? Three hydrogens. Therefore the propanone has 6 alpha hydrogens and it is going to show Aldol condensation reaction. But let us see the structure. This is the alpha carbon, and that alpha carbon is not directly bonded to any hydrogen. Here 3 methyl groups are there, right? But no hydrogen is directly bonded to the alpha carbon. Therefore this structure or this aldehyde is not going to show Aldol condensation reaction. Similarly, this is structure of a ketone. This is the carbonyl carbon. This is these are two alpha carbons, and both the alpha carbons do not have hydrogens which are directly bonded to it. Is there any hydrogen directly bonded? No. 3 methyl groups are there. Here also 3 methyl groups are there. No hydrogen is directly bonded to the alpha carbons. Therefore this ketone is also not going to show Aldol condensation reaction. Now let us see why these alpha hydrogens are important. So if alpha hydrogens are present in aldehydes and ketones, they impart acidity. That means that aldehyde or ketone becomes acidic. We know that a compound which has the ability to donate proton is an acid. Now let us go with the example of ethanol or acetaldehyde. Let us see, the structure is like that, CH3, right? Next, C double bond O and H, isn't it? Oxygen when bonded to a double bond has 2 lone pair of electrons. Now, when a base comes near to it, the base is represented by the hydroxide ion. So what will happen? One of the alpha hydrogen is going out as proton. Why it is going out as proton? That means it is not, this hydrogen is not taking any electron from the bond, and both the electrons that are present in this bond will move to the alpha carbon. That means it is a heterolytic bond fission, unequal cleavage of the bond. Both the electrons are coming to the alpha carbon, right? And the hydrogen is going out as H plus. That H plus and OH minus will give us what? Water. That means water is coming out. Now you see what will happen after donating the H plus. What will remain? CH, H, right? Next C double bond O, right? 1, 2, 3, 4, 2 pairs H, and as both the electrons are coming here, we got an ion. This is a carbon, and carbon with a negative charge. Carbon when bonded to 3 single bonds and one having one lone pair of electron is negatively charged. This is a structure of a carbon ion, right? The interesting thing is that the aldehyde having the alpha hydrogen, after donating the proton, it forms an carbon ion, and that carbon ion is itself stable because of resonance. So we have to know what is resonance. Resonance structures are the structures which only differ in the position of the pi electrons or lone pair of electrons. So here we can see that there is a lone pair here, right? There is a pi, there are 2 pi electrons present between the carbon and the oxygen, right? One is, because one is pi 1, one is sigma 1, and oxygen also has two lone pair of electrons. That means these lone pair on the alpha carbon and the pi electron are in conjugation. Conjugation means they are separated by a single bond. So there is a possibility of resonance. What will happen? These two electrons will form a double bond between the carbonyl carbon and alpha carbon. Parallelly, the pi electrons will jump to the oxygen. Now what is the structure we are going to get? CHH, right? Now double bond, because two electrons have come here. Now we'll get double bond will become a single bond, and oxygen is already having two pair of electrons. The pi electrons will also come. Now oxygen with a single bond and three pair is negatively charged. Now hydrogen, right? So these are the two resonance structures of the carbon ion. If resonance structures exist, the ion has stability to some extent, right? Because of this stability, the aldehyde can donate the proton, right? After donating the proton is itself again stable. Got it? Now let us see how this alpha hydrogen is going to play the role here in the reaction. So I'm going to discuss with the aldehydes having alpha hydrogen. So the basic reaction is that two aldehyde molecules in the presence of dilute base forms beta hydroxy aldehyde, which is also known as aldol, right? I'll discuss why it is called as aldol. And after that, that aldol on condensation, that means when you heat, one molecule of water is going to go out. This step is known as condensation, and after condensation we'll get the product that is known as enal. Enal means the compound will be having a double bond, in for double bond, L for aldehyde. That means final product will be having one aldehyde group and one double bond. Okay, so let us go with the reaction now. So what will happen? Let us see. CH3, C double bond O, and what? H, right? So in the presence of the base, right? In the presence of base is represented by a hydroxide ion here, right? That hydroxide ion is going to abstract a proton, right? That means hydrogen is coming without any electron, and both the electrons are shifting to the alpha carbon. Now which structure will get? C H, then C double bond O, then H. Now both electrons are coming to this alpha carbon. Now we got the carbon ion, right? Now let us see what will happen in the next step. One more molecule of the aldehyde or ethanol will be used. Here you see in the basic reaction I have written two molecules of aldehydes. Now you see what is the structure of next CH3, C double bond O, H. One more acetaldehyde or ethanol. Now we know that the carbonyl group is a polar group, right? This carbonyl group is polar group because of the difference in electronegativity between the carbon and the oxygen. The oxygen is more electronegative. As a result, the shared pair of electrons between the carbon and oxygen will be nearer to the oxygen, right? That's why that oxygen possesses a partial negative charge and the carbon possesses a partial positive charge. That means this bond is a polar bond, and we know that the oxygen, when bonded to a double bond, already it has two lone pair of electrons. Now what will happen? This positive center and this negative center is going to react, right? So which structure will get? You see C double bond O, H, right? Next what I've got? C H2, right? It has the negative center. Now it will form, this lone pair will form a covalent bond with this positive center. New covalent bond will form between the carbonyl carbon of this aldehyde and the alpha carbon of this aldehyde. And parallelly what will happen? The pi electrons of this bond will shift to the oxygen. Now which structure will get? You see this lone pair is forming a bond with alpha carbon, right? C. Got it? Next, this C is having one hydrogen, yes or no? CH and one CH3, as well as it was having double bond. Now the double bond will become single bond. Oxygen is having already two pair. Now one more pair is coming. Got it. This is the intermediate. In the intermediate, the oxygen has the negative charge. After that, what will happen? You see, the water is going to come. The already I have told that the reaction should be carried out in the presence of dilute base. That means water is present, right? The base is diluted with water. Now what will happen here? You see, we know the structure of water, HO, and what? H. The oxygen is having 2 bonds, means 2 pairs already. Now one of the OH bond is going to break. If it breaks, both the electrons comes to the oxygen, and H is going to come out as what? It's come out as H plus. That H plus will take up a lone pair from the oxygen, and it will form a new covalent. One new covalent bond will be formed between this oxygen and this H plus, because H is coming out as H plus. Now what will happen? You see, C double bond O, next H, next CH2, next CH, right? Next CH3, right? Next this oxygen is present on this carbon, right? Okay, now it was having 3 pairs. Now it will be having 2 pairs, because one of the pair will be used to form a bond with the H plus. So we got it. Now what will remain here? OH. Already 2 pair. Now one more, this bond is coming to the oxygen, so OH minus. So you have seen OH has come out. In the first step, OH is involved. That's why base is coming out, right? In first step it was involved. In this step it is coming out. That's why it is a catalyst. So what is this compound you see here? This carbon, right? Carbonyl carbon. This is the alpha carbon. Next carbon is beta carbon. This is gamma carbon. And this beta carbon possesses the hydroxide group. That's why the compound is known as beta hydroxy aldehyde. Aldehyde group and hydroxide group. That's why it is known as beta hydroxy aldehyde, or in common aldol. ALDOL. L for aldehyde, O for OL for alcohol. After that, what will happen? It will undergo condensation reaction. Condensation reaction means you have heated. What will happen when you heat it? The OH group from this beta carbon and this alpha carbon is having how many hydrogen? 2 hydrogen. So one of the hydrogen is going to come out, and when it comes out, there a new double bond will be formed between the alpha carbon and beta carbon. Now you see what will remain here. C double bond O. Next what? H. Next 2. Now we will have how many? 1, because 1 will go out. Next is one single bond between alpha and beta carbon. Now will become a double bond, right? And we'll be having CH. Next CH3. So this is the final product. So in the final product we will be having a double bond between the alpha and beta carbon. So this compound is known as enal. In for double bond, L for aldehyde group. The final compound is an enal. What is the name of this compound? Carbon number 1, 2, 3 and 4, right? So name of the compound is but2-in-L, right? You may be having a little doubt that how this water molecule has gone out. Let me explain this step once more. So here separately I am drawing this compound again, C double bond OH, right? Now you see I am illustrating the structure. This is CH, 2 hydrogens are present in alpha carbon. Next CH, and what is present here? OH, right? OH. Next CH3. How this double bond is formed? That this hydrogen in the alpha carbon comes out as H plus. It comes out as what? H plus. That means it is not taking any electron, and both the electrons present in between them will be coming and forming a double bond, right? And this OH C bond O is also going to break. Now what will happen? The oxygen with a double bond is already having 2 pair of electrons, right? Now these 2 electrons will also come with the oxygen, right? And what will get here? If it comes with oxygen, OH, already 2 pair. Now one more pair is coming, OH minus. Have you seen? And OH minus and H plus will be forming water. That's why water molecule goes out in this step. Got it? So this is the Aldol condensation reaction with the aldehydes having alpha hydrogen. So here we have got the compound beta hydroxyaldehyde. After that it will undergo condensation to form the enal. In the next video will be coming with aldol condensation reactions with the ketones having alpha hydrogens. Thank you for watching. If you have liked my video, please subscribe my channel. Thank you.